Hi, solving word problems simplified. And you can omit the word out here since somehow this strategy also applies to how you deal with real world problems that you experience daily. So in solving word problems, there are only 4 key steps that you must remember. First, given a word problem, read it carefully, maybe once or twice, to get the gist of what's going on out there. Identify the ingredients that makes up that given problem. Once you have that, convert these to variables or convert it to something that you are more familiar with. And then finally, once you have the variables, form it into an equation depending on the relationship that is present in the word problem. So why did I say that? You can omit the word out here. You omit the word out here, given a problem, make sure that you assess that certain problem completely, then identify the ingredients involved out there. Since we're dealing with math, the ingredients are quantities. Once you have that, convert it to something that you are familiar with, something that you can easily work on. In this case, we use variables. And then once you have that, determine their relationship, determine how each ingredient connects with one another. In this case, equations. And all of this, whether in word problems or in real life problems, the key is understanding what's going on in the problem. If you can't understand what's going on in the problem, you'll have a hard time identifying the quantities, converting them to variables, and finding the relationship to form them into an equation. So let us try some examples. First, our goal is to find 3 consecutive even numbers whose sum is 78. So like here, we first identify the quantity that are involved in our problem. Mainly, we are dealing with 3 consecutive even numbers. Let's try to name these. We begin by letting x be the first even number. From here, we can obtain the 2 more consecutive even numbers. Just recall that even numbers are separated by 2, which means that the 3 consecutive even numbers, provided that x is the first even number, is given by x plus 2, and x plus 2 plus 2, or x plus 4. And then once you have that, just go back to the problem and understand the relationship of these 3. That is, our goal is to find these 3 provided that their sum is 78, which means that when we add these 3, the sum must be 78, and that would be our working equation. So let's try to solve for x in this one. So we begin by adding the x's out here, then adding the 2's and the 4's out here to obtain 3x plus 6, subtract 6 out here to obtain 3x equal to 72, divide both sides by 3 to obtain 24 out here. And that answers the problem, since given that x is equal to 24, that would be this one, we can now obtain the 2 more numbers out here. We have our x plus 2 and x plus 4, or basically 24, 26, and 28. These are the 3 consecutive even numbers that we want. That finishes the solution and the answer for this problem. Pretty simple, right? Let's move on to the next one. Second problem. If the length of each side of a square is increased by 2 inches, the resulting square has an area that is 16 inches more than the area of the original square. What are the dimensions of the original square? So you can first try this one out on your own and pause this video for a while. Okay, good. Let's try it out. In here, just to illustrate what's happening, since again, understanding is important, we are first given an original square, and then we increase it to a bigger square by adding 2 to both sides. So let's say this one is s, the side is s. The side of the next one would be s plus 2. Our goal is to find this s, provided that their relationship is that the resulting square has an area that is 16 inches more than the area of the original square. So let's first again assign variables to our cast of characters out here, letting s to be the length of a side of the original square, just like how we did in the illustration. From here, take note that since we are dealing with an original square and a resulting square, it's nice to have a table containing that two, along with their lengths and their areas. So we'll have the following table out here. On the first column, we have here the original square, the resulting square, and then for the second column, that contains their side length, and the third is for their area. From what we have so far, we know that s represents the length of the original square out here, while for the resulting square, we just add 2. So we have here s and s plus 2. Once you have that, take note that for area, the formula is just squaring one side length of the square, which means that the area for this original square is s squared. On the other hand, for the resulting square, take note that from the given, we know that the resulting square has an area that is 16 inches more than the area of the original square, which means that this area out here is given by adding 16 to the area of the original square, which would give us s squared plus 16. But once you have that, take note that another way of obtaining the area for the resulting square is like how we did out here. We square this one, so that would actually give us our working equation. From here, we obtain the equation s plus 2 squared equals s squared plus 16, since these two out here are equal in the sense that they represent the area of the resulting square in two different ways. I put a y out here since I wasn't able to write that one down due to lack of space, but this will be our working equation. Solving for s, the side length of the original square, we'll have first square this one to obtain s squared plus 4s plus 4 equals s squared plus 16. Subtract s squared both sides and then move 4 to the other side will give us 4s equal to 12. Divide 4 both sides and that yields s equal to 3. We can now conclude that the dimensions of the original square must be given by 3 by 3 inches. That answers the given problem. Let's move on to the next one. Third problem. Pi is 9 years older than Bob. 4 years ago, the sum of their ages was 17 years. How old is Pi today? The quantities involved here are ages, and we have two distinctions. One is 4 years ago and one other one is today. So let's try to name these things out here. We begin by letting x to be the present age of Pi. I chose this to be x because that is our end goal out here. So it would be nice if I first name it, and throughout the process, our goal would be finding whatever this x out here. And then again, since we're dealing with plenty of cast of characters, we have Pi, we have Bob, we have today, we have 4 years ago, it would be nice if we have the following table out here. So the first column represents Pi and Bob, the second column represents their age 4 years ago, and then the third column represents their present age. Let's first fill in the present age. We are given that x is Pi's present age. Today, Pi is 9 years older than Bob, which means that their present ages would be x and x minus 9 respectively. Then 4 years ago, we just subtract 4 to these two each to obtain x minus 4 and x minus 13. So once we are able to name each part or each cast of characters out here, let's go back to the problem and determine the relationship that we want. So going back to the problem, we know that 4 years ago, the sum of their ages was 17 years. In other words, adding these two must yield 17. Or in other words, our working equation would be x minus 4 plus x minus 13 equal to 17. So solving for x in that equation, we have add the x's out here and the constants out here to obtain 2x minus 17 equals 17. Move the 17 out here to obtain 2x equal to 34, and then divide 2 both sides to obtain x equal to 17. And once you have that, then we are done. Since going back to the problem, x out here represents 17, which is Pi's present age, and our goal is to find how old is Pi today, which means that Pi is 17 years old today. And take note that this is not a fact if you are thinking that the Pi here represents the Pi man. So Pi and Pi man are different. But that is the answer for the problem. So fourth problem. Bob and Pi drives a distance of 6 kilometers and 7 kilometers respectively. They arrive at their respective destinations at the same time. If Bob drives 3 kilometers per hour slower than Pi, what is Pi's average rate? So just to illustrate what's happening out here, we have here Bob. Okay, this one is Bob. And then let's say this one is Pi. This one is Pi. They traveled a certain distance. So for Bob, he traveled a distance of 6 kilometers. For Pi, he traveled a distance of 7 kilometers. And they arrive at their respective destinations at the same time. Our goal is to find the rate or the speed of Pi. So using these conditions, we can determine what Pi's average rate is. The best thing to do first is, since our goal is to find what is Pi's average rate, let's try to name that thing. So we let x be the average rate of Pi. And since take note that we are dealing with rate, time, and distance out here, I hope that rings a bell. We have a certain equation relating these three. I specifically choose one of them. That is, time is equal to distance over rate. So that came from the triangle out here, wherein this one represents distance represents rate, and time. So basically how this works is that distance out here is equal to, when you multiply this one, that's rate times time. Rate out here represents distance over time, and then for time out here is represented by distance over rate, which is this one. And then once you have that, take note that since we're dealing with time, distance, and rate, plenty of quantities, it would be nice if we have a table of these three. So we have here Bob and Pi and their respective distances, rate, and time. Let's first fill in the distance. Take note that we are given that distance of Bob is 6 kilometers, distance of pi is 7 kilometers. So we have this. For the rate, we are given in the problem that Bob drives 3 kilometers per hour slower than pi, but we know that pi's average rate is denoted by x. In other words, in math symbols, that means that the rate of Bob is x minus 3, and then for pi, it's x. How about the time? Are we given that quantity? No, but we are given the fact that they arrive at their respective destinations at the same time. So their time are the same. Now, how do we find the relationship out here? Since these two are the same, this would be our gateway to relating Bob and pi. Since they arrive at their respective destinations at the same time, this means that time of Bob equals time of pi, but we know the time is given by this formula out here. This means that 6 over x minus 3, or distance over the rate of Bob, is equal to 7 over x, which is distance over rate of pi. These two are equal because they have the same time, and this will be our working equation. Solving for x in this one, take note that we can express this as 6x equals 7 times x minus 3, so that's basically a cross multiplication. And take note that there is a warning out here, since that is not always fine in rational equations. But here, we are sure that x minus 3 and x would never be 0, because if ever that they become 0, then that means that the speed or the rate of Bob and pi would be 0, and that doesn't make sense since they moved from one position to another. So we are sure that these two are never 0. So we can use cross multiplication out there and simplify the problem into a linear equation. From here, let's simplify. Distribute the 7 inside the parentheses to obtain 6x equal to 7x minus 21. Move 7x to the other side to obtain negative x equal to negative 21, and then multiply negative 1 both sides to obtain x equal to 21. And then from here, that is actually what we want, since 21 out here represents the average rate of pi. So we have here that the average rate of pi is 21 kilometers per hour. Let's move on to the last item. So fifth problem, pi wishes to mix two types of coffee beans. One costs 40 pesos per kilogram and the other costs 60 pesos per kilogram. How much of each type must be mixed to obtain 50 kilograms of coffee that reasonable costs 55 pesos per kilogram? Now this one is a little bit scary, but as long as you can simplify the problems into a cast of characters that we know how to relate with, then it would all be simple. Just take note that I use a peso out here since I'm not really familiar how much coffee beans cost in other countries. Just to illustrate a little bit about it, so take note that you see this one, we are given the type 1 coffee, the first type, and then we are given the second type. Our goal is to mix them out here. So let's say that we mix them out here, provided that this mixture has the following condition out here. Our goal is to find how much of type 1 and type 2 coffee must we buy. So it would be nice if we first name the amount out here or here. We let x be the amount of the first type of coffee. So it could be the second or the first, it doesn't really matter. I just chose to name the first type of coffee. It would all have a relationship later on. And then from here, since we have two types, so it would be nice if we have a table that distinguishes the two. And then since we have plenty of quantities out here, the amount out here of each type, we have the price of the coffee and then their cost, or in other words, you use the fact that 40 pesos per kilogram. So that's when you multiply them. So that's plenty of quantities out there. So we'll have the following table. The first column, we have here the type 1 and the type 2 coffee, our goal or the mixture. And then the second column would be the price of the coffee per kilogram, the amount of coffee, which is the kilogram, and then their total cost, or when you multiply these two, what will be their total cost. Let's fill in each column, starting with the first column or the second one basically. Take note that for type 1, we are given that it costs 40 pesos. For the type 2, it costs 60 pesos. And our goal is that it costs 55 pesos. So we'll have the following out here, 40, 60, and I forgot, but there should be a peso sign. Let's fill in the third column. So we have here the amount of coffee. Take note that we denoted x to be the amount of the first type of coffee. So this one must be x. And then from there, our goal is to obtain 50 kilograms of coffee. So this one is 50. How about the type 2? That would be 50 minus x. Since we know that this goal is a mixture of the two, which means that its total weight, the kilogram of the coffee, would just be the same. By that I mean, when you add these two, it must result to 50. Finally, the total costs, again, we just multiply this, and then this to obtain the following out here. So now that we have our quantities, we were able to name them, our cast of characters are complete. It's time for the story or the relationship of these. First, obviously, we can't get any relationship out here. They are just quantities. Same for this one, since we know that when we add these two, we just get this. So we won't really get any good relationship out here. So we look at the total cost out here. Take note that we are sure that when we add these two, the cost must be preserved to our goal. In other words, we obtain the equation 40x plus 60 times 50 minus x equals 55 times 50. Since again, the cost is the same because the mixture, our goal, just came from buying these two types of coffee. So the cost would remain the same and this will be our working equation. Again, I put a y out here because I lacked space. You just take note of what I said. So we use this equation to solve for x and 50 minus x, the amount of coffee of the first and the second type respectively. So solving for x, we first distribute 60 out here to obtain 40x plus 3000 minus 60x, and then multiply this to obtain 2750. Add these two and move 3000 to the other side to obtain negative 20x equal to negative 250. Divide negative 20 both sides and that would yield 25 over 2 or 12.5, and that is for x. So solving for 50 minus x, we subtract 50 by 12.5 to obtain that the type 1 coffee would contain an amount of 12.5 kilograms while the second amount would contain 37.5 kilograms. And that is the answer for this problem. A scary problem that we were able to simplify into just a simple equation and obtain the corresponding answer. That's how we solve word problems. And some final words to live by. So a few words from two wise men. First is George Polio, a famous mathematician. He said that it is better to solve one problem 5 different ways than to solve 5 problems one way. Again, 5 different ways than solving 5 problems one way. So this is important whenever we tackle math problems and problems of real life in general, because we need to be flexible and we need to widen our perspective to solve a certain problem in multiple ways. For our second wise man, that would be me, PyMath. So help me provide better math content to you by answering the Google form in the description below. I think it's just a simple set of questions, probably 1, 2, or 3, just asking you what you like about this video, what you want to see more, and just basically help me cater my content for you, to your needs, to your wants, to what topics you want, and so on. If this is too hassle for you, you can just comment it down below and I would be glad to read that one. So these are 2 things to live by, and yeah, I hope you enjoyed that one. That's it. Have a nice day.